We're going to be taking a look at numbers 23 to 25 on activity 112, simple machines practice problems. And in this one, we're all going to be dealing with problems that deal with the wedge. So here they have hydraulic shears that are used in manufacturing to cut large sheets of metal. Using hydraulic pressure, the machine pushes a wedge that is shaped like an inclined plane, not biface like an axe, to cut the metal. So imagine one side or a blade of a pair of scissors. In this problem, a shear has a 1/4 inch thick cutting blade with a 45-degree slope between the two sides of the blade, and the hydraulic pressure applies a 2,000-pound force to the wedge. So what this looks like, if you're kind of familiar, it almost looks like this, like an inclined plane, and it's very similar like the end of like an X-Acto knife kind of blade that you would have. So here, just to go along, they go through and it says it has a 1/4 inch thick cutting blade. I'm going to draw in a little dash line here to show. So the portion that's doing all the cutting is right here on the blade. So right here on the sloped edge or the blade there, and this allows us to go through and see that. So here they end up having, so from here to here they say this is a 1/4 of an inch. And then the other thing as well is, so is this. And here it has a 45-degree slope, so that's the 45 that we have being represented by the angle. And then also they're providing an effort force of 2,000 pounds. So to be able to push down to cut those large sheets of metal. So there's kind of like what our image or what our sketch would kind of look like to go through and kind of help us answer some of the questions as far as that goes. All right, so now let's go ahead and take a look at number 24. So we're gonna use some of that info to help us solve here. So they're gonna ask us what is the length of the slope? So on this scenario, as you remember from the sketch, we can utilize Pythagorean Theorem, much like we did on our inclined plane problem in a previous video, to go through and to solve for some of those things. So as we take a look at that, I'm going to go ahead and put this in decimal form. 0.25 squared plus 0.25 squared is equal to c squared. And I'm going to have to take the square root of this to be able to cancel those portions. And I can go through and use my calculator to kind of help out with some of those problems. So second square root, and do another parenthesis so that way that we're just going to be worrying about squaring those values. And here again, just kind of looking at our significant figures, as we kind of see they as far as especially with fractions and things like that, we're going to be taking a look at just kind of maybe playing along with doing about 3 significant figures, 0.25, maybe one more for an extra digit here. So I'm going to go ahead and round this off to that C 0.354 inches. Now, as we take a look, we've got to look at the ideal mechanical advantage. Now, for a wedge, they say we want the length that is perpendicular to the height and then divided by the height. So this is going to be a little bit of a tricky scenario because we want to see like what is the length that's perpendicular to the height. So let's go ahead and take a look back at our sketch here. Here's our height of our blade. And you would think in an inclined plane that we would use most of the time the length for a slope on a ramp, we want to use the sloped edge. However, we want to use the dimension that is perpendicular. So this dimension is running this direction. The one that would be perpendicular would be this one right here. So not the sloping edge that we have there. So when you look at this, the height is 1/4. That length that we want to use is also 1/4 because that's what's going through and doing a lot of the cutting. So as I look to apply this into the formula, IMA 0.25 over 0.25, and now I can go through and see that my IMA is going to be a 1-to-1 ratio for the wedge. And this goes through and finishes up all the problems dealing with the wedge, and later we'll look at the last set of simple machines dealing with the screw. So last set of problems that go along with it.